Okay, for this video, I'm going to show you how to calculate the acceleration using the gradient of a velocity time graph. Note that the line that you see inside the video, it was actually previously left from another video. So you're not seeing it, don't have to worry about it, but I'm sure you can catch up as I go along. Now, how do you find the acceleration using the gradient of the velocity time graph? Now you look at the shape of this graph, it looks very different from the first two videos which I've done. But despite that the shape looks different, bear in mind the concept is still the same. And that is acceleration equals gradient of velocity time graph. You still find the gradient, right? Doesn't matter the shape, you still find the gradient because that is the basic. That's a very basic fundamental you need to know. Right? So we're going to isolate two sets of coordinates. Right? You're going to isolate two sets of coordinates. You can see at time equals 0, velocity equals 10 meter per second. Already one set over here. Very nice. The other set we want to isolate will be, let's say, at 8 seconds. Time equals 8 seconds. Velocity equals 6 meters per second. And you have a very nice coordinate here. Okay, you have a very nice set of coordinates there, right? So when time equals 8 seconds, whoops, these seconds look a bit like a 5. When time equals 8 seconds, velocity equals 6 meters per second. Again, we start out with rise over run. And in the earlier video, I already mentioned time can only increase, right? Time can only increase. So this is your run, and this is your rise. Time can only increase. So your time increases from 0 to 8. How about your rise? When time increases from 0 to 8, when time increases from 0 to 8 seconds, okay, velocity decreases from 10 meters per second to 6 meters per second. Now note, decreases. So the velocity actually becomes smaller, right? So your final velocity is 6 meters per second. Your initial velocity is 10 meters per second. So your rise actually is 6 minus 10. So this is your rise. 6 minus 10 equals minus 4 meters per second. And your rise is actually minus 4 over 8. So that's meter per second and this second. So what you get is minus 0.5 meter per second equals minus 0.5 meter per second square. minus. Alright? You see, your velocity decreases from 10 meter per second to 6 meter per second. And now, you found that your gradient is negative. Your acceleration is also negative. So what does this mean? Okay, what does this mean? Alright? So this means if acceleration is negative, the object is decelerating. The object is decelerating. Hence, acceleration equals minus 0.5 meter per second square. Deceleration, okay, when you write deceleration, you can ignore the minus sign, because the meaning of deceleration means slowing down. Okay, the meaning of deceleration means slowing down. You can just write 0.5 meter per second square. And there's another word for deceleration, it's called retardation. Not very commonly used, but you see that on and off, right? So you see here, acceleration equals minus 5 meter per second square, minus 5 meter per second square. And when you describe it, see the object decreases by 0.5 meter per second. And the acceleration is minus 0.5 meter per second square. Right, so the calculation and the description all ties in together.